Hi, LDNWebPerf. Happy New Year. Thanks for having me again. Is my microphone on? Excellent. So my name is Dora Militaru. I'm a developer here at the FT. And before I go any further, I have to warn you that this presentation contains lots of flashing content because I cannot help myself with GIFs. So if that makes you uncomfortable, then please let me know now. Everybody okay? Great. I would like to talk to you today about, I like giving talks that start with a W. So who's afraid of Webpack? First of all, throwback time to the early days of JavaScript development. Do you remember when you have to copy paste the library, possibly jQuery, into a vendor folder and then rely on the global scope and concat everything in order, and then probably have to deal with namespace issues. So that was fun, but we're having more fun now because we've sort of warmed up to a common module format, and we've got a centralized module registry, and we use the script tag for regular scripts in the global namespace, but we also support module for modular code with implicit imports and exports, and that is really great because now we're all writing highly self-contained code with distinct functionality that you can shuffle and remove and add without disrupting the system as a whole. So with this modularity comes an increase in complexity, and it is actually much harder and more complicated nowadays to deliver JavaScript code to the browser. So anyone here, have you used Make and Gulp and Grunt and stuff like that? Okay, everyone. Great. So they're build tools that tackle repetitive but essential code tasks like sort of minification, optimizing, testing, CSS post-processing, pre-processing, sorry, and deployment. And we've been using those for a long time because they're great tools at a high level. But where they fail is when you need to start splicing various assets together and creating bundles. So as a consequence, just because we've come to expect modules and dependency management and dynamic loading as basic requirements of writing good modern code, there's a whole new set of tooling that's come in, and those are bundling tools. So some of the most popular are Browserify and then JSPM and Fusebox and Rollup and Require.js and Brunch and Steel.js and Parcel and obviously Webpack. So yeah, I'm here to talk about Webpack. Webpack's been around for a while, I think since 2014. Any Webpack users in the room? Okay, that's a fair few. Don't worry if you haven't used it or heard of it before. I'm going to try to bring you up from the basics. So can the Webpack users raise their hands again, please? And you can put your hands down if you're unthinking happy thoughts. Fine. Cool. So yeah, most people have a love-hate relationship with it, including myself, because it's a bit of a black box and it's packed with powerful but mystifying features that can only be unlocked by some bamboozling config that you've copied off of Medium, written by a genius wizard. And I am not a genius nor a wizard, but I'm going to try and take you through the basics of Webpack. And hopefully by the end of this talk, you'll walk away with some confidence and maybe some new knowledge. Okay, so what is Webpack? It's a module bundler. It's a static build tool, so it's not a module loader. It doesn't do anything like that. Its main purpose is to bundle JavaScript for usage in the browser, but actually it's also capable of transforming and bundling and packaging just about any resource or asset. Any time one file depends on another, Webpack treats it as a dependency. And in a way, everything is a module in Webpack. So this allows Webpack to take non-code assets like images or web fonts and also provide them as dependencies for your app. So Webpack can handle almost everything you can throw at it. So you can even bundle GraphQL queries or inline SVG with Webpack. Webpack works in any stack, in any environment, and it works without making assumptions about your workflow. So in general, when what Webpack does is does really well is dependency graph stuff. So you can load what you need when you need it. It does tree shaking, which is the elimination of dead code. There are some caveats there with the tree shaking. It's not perfect. So when a tool can't guarantee that a particular code path doesn't lead to side effects, then this code may remain in your bundle even though you might not want it to. So this usually happens when you like re-exporting functions imported from third-party modules, or when you have third-party modules that Webpack or Minify cannot interpret. And then it does code splitting really well. So you can reuse code, and it gives you a lot of control over that code splitting. We'll go into that in a bit. Webpack also does asset management. So static files, JSON, it transpiles, does templating, styling, linting, testing, works with frameworks, and it also supports asset hashing. But long-term caching is complicated, and we'll go into that as well. Okay, so Webpack is a vast-ish ecosystem of things. It's got a config, which is a module in itself. It's got a CLI, it's got a Node API, it's got a Loader API, it's got a plugin interface, and it's got lots of other features too that I don't claim to understand, but the docs are getting better now, so let's just gloss over that. So yeah, Webpack is incredibly configurable, which can make configuring it incredibly confusing. So most people start by copying the boilerplate template off of Medium or Stack Overflow, and then mavericks and masochists sometimes dig deeper. So Webpack starts with a config file. That's the base of it, and that's probably where most of the complexity is. But if you understand 4 core concepts, then you've mastered this config, and you don't need to copy-paste something complicated that will just bamboozle you. So the 4 of those are entry. This tells Webpack what to load. That's usually where you specify maybe the canonical route for your module or something more complex depending on your setup. And it's got output, which tells Webpack where and how to distribute the resulting compilation, also known as a chunk or a bundle. Then it has loaders. These are basic transforms. These apply to individual modules, or module types, actually. And it tells Webpack how to interpret and treat specific files. And then you have plugins, which is everything else. So plugins are sort of overarching, build-wide things that you can apply to the general config. Now, this is what a config looks like. You don't have to write it in JavaScript as well. Some people have attempted this in TypeScript. There's some amazing posts. Did not have the patience, but it looks like that. So you've got entry, output, rules, and plugins. You only really need entry and output to have Webpack actually produce a usable JS bundle. Rules, loaders, and plugins are extras where you tell it to do various other things. So let's try and dig deeper into each of those bits. So entry looks kind of like that. I've got a couple of examples there. An entry point indicates which module Webpack should sort of use to begin building an internal dependency graph. That's what Webpack does. That entry is often, for simple setups, it's often the canonical root of your app. It's where all the includes and the requires start coming in. And that property can be a string, or it can be an array if you've got multiple entry points, or it can be an object literal. So if you look at the bottom, you've got 2 entries. You've got app and vendors. And those properties, all they do is tell Webpack what the name of the chunk should be in which those entries should be bundled into. So once Webpack goes into an entry point, it will start to figure out which modules and libraries that entry point depends on, indirectly or directly. So it builds something like a dependency graph, which looks a little bit like that. And then from there on, it builds this graph recursively until it includes every module that your application needs. Okay, output. So top-level output key contains a set of options that instruct Webpack where and how to output your bundles. or assets or anything else you might bundle or load. And it also has some magic substitutions that I've commented out at the top. So, okay, if your configuration creates more than a single chunk, so you have multiple entries, or you're using something like the Commons chunk plugin, which I will talk about, then you should use these substitutions to ensure that every bundle/chunk has a unique name. So these are things like ext extension name, hash, which is a build hash, chunk hash, which is the chunk hash, and content hash, which is something very specific to extract text, which I will not go into. So yeah, the output property has many more configurable features. Like I said, the Webpack docs have gotten a lot better with v3. To give you an example, public path down there can be useful in a lot of scenarios. It lets you specify the base for all the assets within your app, and you could point it to a CDN, for example. So that was output. On to loaders. So Webpack itself only understands JavaScript, but it enables the use of loaders to pre-process files so you can bundle any static resource beyond JavaScript. So essentially, Webpack loaders transform all type of files into modules that can be included in that dependency graph. Now, a loader is a node module that exports a function which is called when a resource should be transformed by that loader. The loaders can access Webpack's loader API on the this context in the function. And the loader API is very well documented. So if you are tempted to write your own loaders, and I will give you an idea later, then please do it. So Webpack itself has quite a few core loaders that we tend to use a lot, like the URL loader, for example. You can find them in the docs at webpack.js.org. And there is a huge community contribution list maintained in the awesome Webpack repo that I've highlighted down there. I'm not going to go into the specific loaders. This will depend on your stack and on your specific configuration, what you want to do with your files, whether you need transpiling, whether you need baking GraphQL queries, whether you need parsing of CSV or you've got SCSS. That all depends on your specific setup. But this is what a loader syntax can look like. Loaders are codified in rules. Rules are arrays of objects. Every loader has a test, which is a regex, which tells Webpack which file to process, which types of files to process. Then it can have a loaders array, which, just to make it less confusing, is read from right to left. First of all, we evaluate with the Sass loader. Then the output, which is obviously CSS, goes through the CSS loader. Then it goes into the style loader. And then you can include or exclude paths or strings or regexes in either objects or arrays or strings. Webpack kind of does that in a few places. So yeah, to recap, at a high level, loaders kind of do two things. They identify which files should be transformed by a certain loader, and that's the test property. And then they transform these files so that they can be added to your app's dependency graph. This is an example of a loader that uses just a single loader, so it doesn't specify loaders. And you can see there's an options object there. And that options object will be very specific to the loader itself. So depending on the loader, I would just go in the docs, go in the README, see what it needs. That's your configuration object, and you can inject a lot of stuff into that. That is a very basic Babel config. So yeah. Loaders hopefully should be pretty clear by now. They're actually very simple. It's very easy to write your own loader. Let's go on to plugins. So while loaders are used to transform certain type of modules, plugins are of a broader scope. They go across the entire build and can be leveraged over a wide range of tasks. They range from bundle optimization and minification all the way to defining envars, and you can also do compression and things like that. And something that maybe perhaps you didn't know is that plugins are the backbone of Webpack. Webpack itself is built on the same plugin system that you use in your Webpack config. So many objects in Webpack extend a tappable class, which exposes a plugin method that's used to then inject custom build steps. So most features within Webpack itself use this same plugin interface. So a Webpack plugin is actually just a JavaScript object that has an apply property. It's not more complicated than that. And then that apply property is called by the Webpack compiler, and it gives access to the entire compilation lifecycle. So yeah, since plugins are of that shape and they can take arguments or options, you have to pass a new instance to the plugins array in your config. Other than that, using plugins is pretty straightforward. Because Webpack is such a cool free and open source thing, and it's got huge community maintenance, that docs tend to be pretty good for all the stuff they feature. So that's where you'll find any options for the config, if any. There are loads of plugins that Webpack provides out of the box, notably Uglify.js plugin. We'll get to that one in a bit. But there's also a huge base and an ever-growing base of Webpack community plugins. And there's a list maintained at Awesome Webpack again. Okay, so before I go on to other things, I'd like to offer a couple of tips here. The first one is that you can actually have multiple configs in one and pass that as an object to Webpack. And it's as simple as putting the config objects in an array. Why would you want to use that? Various reasons. So for example, you may want to create separate bundles for transpiled and not transpiled code. So you may want to have pure ES, and you may want to have like, transpiled code. Or say you want to do build time compression and you want to do Broccoli stuff and Zopli stuff and gzip stuff. And you want to do it at, when you run the Webpack command that compiles stuff. You could just put it in the same config and it makes it easy to see things. Pro tip number 2, so if you like splitting files and not having all the config in one gigantic file, if your setup is a bit more complex, don't use object assign. Webpack has Webpack merge for this, and it merges 2 or more config objects in a slightly more resilient way. So this example here, there's 2 configurations with it merges the first bit of configuration to each of the subsequent ones. It's by Survive.js. Please use that. Don't use object assign. You might have some really weird side effects. Okay, so we're done with the hard bit. You feeling a bit more okay about the config? That's on the basis kind of all you need to get going. There's a Webpack CLI, and so that you can configure and interact with your build. So for the most part, we just use that to kick off the process using configuration file and a few flags. The most important flag is probably Webpack -p, which kicks off Uglify for production. Another thing that I like to use is Webpack JSON stats. There's some cool things you can do with that stats JSON. It's just a dump of the build stats in a JSON file, and you can add various stats to that if you're interested in various metrics around it. And you can also do debugging and profiling, and I find that particularly useful in the case of early prototyping. So yeah, speaking of profiling and early prototyping, there are some visual tools to help you with that and help you debug your builds. First one is Bundle Analyzer. It's Webpack Bundle Analyzer on NPM. What this does is you simply put it as a plugin in your Webpack config, and hopefully in your dev config, because you can have dev and prod. And that kicks off a process. It opens this interactive chart in a browser that provides a map of basically your chunks in the various bundles. And it's zoomable and interactive, and you can see the path size and the original size and the path and all of that. So this beautiful piece of work here with the clashing colors is one of our most complex front-end facing apps. It's the article page on ft.com. And what you can see here, if you examine it, is whether you have duplicate bundles, whether you can do some optimization, whether some things in a place you completely didn't expect it to be. that wouldn't be good. There's another one. It's Webpack Analyzer. So that's JSON file that you can generate. You can upload it to webpack.github.io analyze. It's not getting sent off to the server, so you're not actually sending them your build data, because that would be pretty funny. It offers a wealth of features. So it shows you the whole dependency graph that you start with, and then it shows you the same for the chunks and how they interact with each other, and that's really interesting. And then you can see your assets in order of size, and you can see some build stats around that, and you also get warning errors, and you get some pretty basic hints around optimizing your config. But that one's a really interesting one, and it's very, very easy to use. There's another one if you need to do presentations to your WebPerf peers. It's Webpack Visualizer. So same sort of principle, upload stats JSON to another URL, and you can see on a lovely radar graph. It's not a radar graph, I got that wrong. I don't know, it's some sort of graph. You can see what's taking up the most of your bundle size, and you can see, roughly how much images are part of that, or where the CSS ends up in. So that's another way of displaying sort of size stats. There's another one. This is if you want to impress your friends. It's actually interactive dependency graph that floats around in space. Why? No idea, but it's really good because if you click on something, you see exactly where the module is, and you can drag it around, and it looks very pretty. And if you're not into all that colorful, funky stuff, there's something rather more useful and accessible. It's a little bit like the Webpack Bundle Analyzer, but the main difference is you pass it a dist file or a source map rather than your build stats in JSON. And it outputs this, or the bundle stats, in a very simple tabular way that has JSON in the background. So you might want to use that for something else. Okay, so we've done the basics, and it's time for some Webpack performance incantations. So the first one is, well, the first few ones are things that lead to either smaller bundle sizes, faster runtime, or both. Scope hoisting. So scope hoisting is the flagship feature of Webpack 3. And one of Webpack's trade-offs when bundling is that Webpack wraps every module into a closure because it needs something that feels kind of like JavaScript. So this overhead makes it slower for your JavaScript to execute in the browser. And like Rollup has this feature, Closure Compiler, you can actually make Webpack concatenate the scope of all your modules, obviously, the common scope, into one closure so your code executes faster in the browser. So enabling that is sort of really easy and risk-free, and some users report up to 50% smaller bundles. And you should do it anyway, but especially if your app is composed of very small bundles, the overhead might actually increase. The overhead of having that closure might actually increase the size of your JavaScript very significantly. So this one's definitely worth doing, and it's one of the plugins that Webpack has in its core, and it's called Module Concatenation Plugin, and it is that simple. So yeah. The other ones that Webpack can do on core plugins are Minify and Uglify. So when you run Webpack with a -p flag, which, by the way, you can use npm as a task runner, and you add the Uglify.js plugin, which has loads of options, you can expect up to 60% reduction in bundle size. I mean, that makes sense. That's what uglification does. If you want to be sort of quite cowboy about it, you can chuck another few plugins in there, and that for me would be quite an aggressive minifying strategy there. So we've got the dedupe, we've got Uglify, and we've got aggressive merging plugins. Just look at the Webpack core plugins in the Webpack list and see which ones sound like they would be suitable for your build. One caveat there. So although latest Uglify.js can handle ES6, Webpack 3 is based on some version that can't. So if you're going to be minifying ES6, use Babel Minify Webpack plugin rather than Webpack's Uglify.js. Otherwise, your code will break. Okay, here's another interesting one. So build time compression. If you're serving compressed assets, it's probably likely that you're either doing them via Express or the CDN. You can do this in Webpack. There are various plugins for various uses. I think the most common one is compression plugin. It's very configurable. It uses gzip and gzip things. And you can even specify things like minimum compression ratio, so you know you're getting the sort of maximum win trade-off situation. You can specify a threshold over which you compress and things like that. There's Broccoli support, there's Zopli support, there's a few other sort of compression plugins. And built-in compression is really interesting because if you're doing it via Express, that's going to save you loads on your CPU, and your, might have like a cheaper dyno or something. And also you can control very finely how you do it in a JavaScripty way that other developers can understand, because I am not so good with VCL. Okay, so another sort of Webpack wizardry thing is loading what you need when you need it. So Webpack supports this thing called lazy loaded modules, which is a very involved change, but it's actually a fantastic performance win. To use this, you're going to need Babel, of course. You're going to need a Babel plugin syntax dynamic import. And if you use ESLint, you're going to need another thing. Otherwise, the lint is going to complain, but I'll let you get that set up. I'm just going to try to convince you that it's really worth doing. So instead of having import something from something else, you can do import asynchronously, which returns a promise, or you can just write really nice async await stuff and your code will look beautiful. Now, why would you do this? So say you've got a button that triggers a modal or something with a really complex form with lots of validations and so on. I don't want that to block on my, for the first time round. So someone might not even click on it, and there might be loads of buttons like that. So what I want to do is split those codes into chunks and load them only if and when I need them. So I can put this async await in the event handler, and that would be a massive perf win. And then once you've downloaded that chunk, it's cached. So it's a really, really cool way to work with it. And there's also one thing that Webpack 3 supports, something called magic comments. So you can actually tell the async import where to load a dependency from, in which chunk. So you have a really fine-grained control over your chunk selection there. There's another thing that you can do. Obviously, Adi Osmani made it. So this is something that basically inlines critical CSS above the fold. How it does it, I'm not quite sure. Magic, I have a hunch that it sort of looks at your HTML and looks at your SCSS and then does some bamboozling magic, but it's actually super simple to configure. Now, I haven't had a chance to play with this. Has anyone done it? Of course, Patrick. I would love to experiment with this. The reason I haven't is because of this, because we have lots of CSS and it takes ages to build with Webpack. So I want to share a trick with you that's probably going to be quite controversial, but hey ho. So we've got a little bash script that I've rewritten as a make task, just to be a bit extra. So this does basically what you can make it do what Webpack does. So it starts with Node Sass. It's got PostCSS and auto prefixer, which hopefully we're all familiar with. And then you can just add whatever processing plugins you want in there. It takes entry, it takes output. Obviously, you can configure this. This takes like 3 seconds on the article page. Doing it with Webpack takes, Simon, can you tell me?
30, 40 seconds?
Yeah, so that's a huge reduction. So we're willing to make this this compromise for faster builds. Okay, the next round of perf optimization is actually caching. So you know, like cache and validation is hard. No, it's not with Webpack. It does it for you. And there's an article by Tim Sebastian that predictable long-term caching has a lot of edge cases with Webpack that I never thought about. When I read this article, I was just mind blown. It was really interesting. So I really recommend it. This is how Webpack does hashed assets. So you can pass it like, you know, a hash substitution. That one's regenerated in every build, even if nothing has changed. But you can have chunk hashes, and they're supposed to be consistent between builds, but there are caveats and edge cases, and they're very well documented in Tim Sebastian's post. And I sort of got to the end of it, and I felt his frustration, but it was such a wonderful piece of debugging. I really recommend you try and find the article. So the solution is trying to, for now at least, trying to hack your way with some deterministic caches. There are other hashing plugins there, or you can roll your own. Chunk manifest plugin and Webpack chunk hash work really well as a workaround for deterministic hashes. They seem quite stable. That's a basic config you can use. Chunk manifest is very configurable again. So if you have a hunch that your hashing might not be working, you can try other methods too. But bear in mind that deterministic hashes will slow down your build time lots. So try and only do it in your production config. Right. Another thing that you can do is vendor bundles. This is another core Webpack plugin, is the common chunk plugin. You can specify some dependencies in a vendor entry array, and Webpack will bundle them all together into one vendor chunk. And the idea is that you know that those dependencies will change a lot less than your code, and you have better hopes of caching that one. And obviously, you have to be mindful of script execution order and things like that. You can also do automatic chunking. So you can ask Webpack to find the code that is in common and stick it into various manifests and chunks and so on. And the only setting that you really get to tweak here is that min chunks. So in the first example, min chunks determines how many bundles a module must appear in before it's stuck into a commons chunk. So that min chunk is 2. If it only appeared in one of like 3 of the 3 chunks up there, sorry, the 3 entry points up there, it wouldn't make it in a commons chunk. But otherwise, it would be removed from whichever, from both or all 3 modules it appears in, and placed into the common.js chunk. Min chunks in Infinity just creates the commons chunk, but doesn't move the modules into it. So yeah, if you want to do things like moving the Webpack runtime around depending on your script loading order, that's when you start caring about that and manifests and so on. Vendor bundles, that's what we do. So we have a fairly complex architecture based on microservices, like articles page, stream page, MyFT, they're all microservices, and they all have slightly different front-end setups, but the tooling that builds them is called NUI, and Reese had a great talk about it a couple of months ago. So NUI has some opinions about some common dependencies that it wants to version control in a very strict mode. So it creates a bundle with these, and it sticks it on the window object. Now, Webpack has an option called Webpack Externals, and what that does, it provides a way of excluding dependencies from the outputs. So in this config, any app entry points that would get passed through this would have things like NUI or ODate stripped out and replaced with a thing in the window objects. So the created bundle relies on that dependency to be already present in that consumer environment. But this is a cool way if you have microservices to sort of hack your way into version control and things like that. Okay, and the last one, which I found out about recently, and I thought, wow, that's amazing. So, say, have you ever had bad data on your phone and your page just either you accidentally reload it or it reloads itself and it's so lost and you can't read a static news article? So that could have been avoided if once the website had loaded fully, it had cached better. And Webpack actually has a plugin that spins up Service Worker and has fallback on app cache to make that possible for you. And that's called Offline Plugin. Okay, so if you want to read more about these optimization, Drew Powers has a really great article where he ranks these in terms of trade-off, effort implementing, and performance gains. And I also recommend you read it. It's called High Performance Webpack Config for Front-End Delivery. Okay, so I want to share some food for thought, some secret sauce, edgy stuff, I hope. So 63% of browsers worldwide now support ES6 modules. So can we please start shipping it on the front end? Because that would be awesome, because depending on your browser support policy, and I'm very lucky here at the FT, and the transpilation overhead, you might save up to like 50, 60% in bundle size, and also like hipster JavaScript. So I'm really excited about this. What would that Webpack look like? So you would have a config array that generates two chunks. You won't transpile the ES6 code. I've prefixed it here with ES6 just so you can see the difference. You can obviously add whatever loaders you need and rules. You might need to do other stuff with that code. And you would also generate, for that same entry point, you would generate another chunk that's transpiled with all your basic Webpack config. Why would you do that? Because in the browser, when you delivered it, it would look like this. So browsers that support type module support ES6 modules. So you would load the smaller entry point, app.main.js. Otherwise, you fall back into the big transpiled bundle. If the browser supports module, it will ignore no module. Because we've got defer, it respects the order. So if you've got ES6, that second thing never gets called. So you've just shipped a lot less JavaScript to your client who supports it. And that's obviously a really big win. So can we ship ES6? It depends. So CommonJS modules, if you have loads of NPM dependencies or dependencies of dependencies, they probably need to be rewritten to ES6 using import syntax. Or you can risk it and trust the new modern thing they have, which is package module in a package JSON, which might have the not transpiled code version. Ship with it. So yeah, that's Webpack 3. Webpack 4 is coming up. And I think it's about, I don't know how far away it is. So what's new in Webpack 4? These guys know how to make a breaking version. So lots of things are new. First of all, the plugin system has changed completely. Whereas now you have, you extend tappable. Now they've changed that to composition rather than inheritance. And you have to have a new hook in the plugin. So if you're a plugin writer, or if you own publish plugins, that's going to be fun. And then things like the dependency graph algorithm has changed, and there's some implementation magic around how plugins work as well, and how like taken out of the because most plugins will be in the hot path, and I can't remember exactly what he did, and he's very critical in the post, and I haven't looked at the source code, but it just sounds like, yeah, everything's going to break. So I'm really excited about this. So there are some posts by Tobias Koppers, the founder, one of Webpack's oldest contributors, on the official Medium with all the juicy bits. It's still about a month or so away. If you're interested, I have included all the resources I've spoken about on like Webpack reading list, and also we're hiring and it's awesome. Thank you.